Hi there. I thought I would do a little demonstration of the SharpSky focuser temperature compensation in action, as it were. I've sort of connected it all up here. It's connected to a laptop which is clearly out of shot, running the latest driver, and it's just it's all connected to my client program that I wrote. Here's the control box, powered up, so you can see the little light there flashing. I'll put the lid on so it's not too distracting. Okay, I've got the normally I use the temperature sensor on the top of the actual motor housing, but for the purposes of this demo I've disconnected that sensor and I'm using a second sensor which is plugged in here on the side of the controller. So this is the temperature sensor, this is the motor, this is a USB connection, and this is the manual control. So the manual control is up and running. I'll move my bag of peas. You can see the direction lights there flashing, and you'll see those flashing during the temperature compensations demo. So currently, bear with me 1 second, we've got a temperature in this warm water of 37 degrees. I've got it set to 10 steps per degree C with a hysteresis setting of 0.2 degrees, so it doesn't hunt around too much. So right, okay, so it's at 37 degrees. So if I take my temperature sensor to simulate a cold night and put it in my peas, and then if you keep an eye on the pencil, it does the update every 10 seconds. So there will be a 10-second gap, and then it will make an adjustment. So there's made an adjustment, and then there'll be a 10-second gap as it evaluates the temperature, and then there'll be another adjustment. You can see the direction light here flashing. So this is simulating the temperature dropping, and the automatic compensation system is now winding the focuser out to compensate for the scope tube assembly contracting as the temperature drops. Any excuse to get a bag of peas out. So we'll give it a little. I'll check the temperature a minute. Sorry, what I'll do is as this demonstration is running, the driver is logging the temperatures and positions to a file, so you can review what actually happened. So I'll upload that file so you can have a look at it. It's a bit difficult to show the demo and the PC at the same time. Okay, that's 1.75 degrees on that sensor now. So we'll hopefully should go sub-zero because the peas have been in the freezer. Give it another 30 seconds. That's minus 1.38 degrees now. You've got to take into account that the temperature, with it set as it's set at the moment, the temperature's got to move by 0.2 of a degree before the motor will actually move, so that you don't get random sort of hunting around, you know, because the temperature is evaluated to two decimal places. So if you didn't have some hysteresis, the motor would be constantly chattering backwards and forwards as the temperature fluctuated, which is obviously not what you want on a scope when you're actually imaging. Okay, temperature is now minus 5¼ degrees. So if I take the sensor back out of the peas, it's still temperature's still dropping. You can see that the pencil's very slowly rotating. Well, from my point of view, clockwise. Might be anti-clockwise from your point of view. So if I take the sensor out of the peas and put it back in the warm water, I've gained some peas. So now the temperature is obviously going to go in the opposite direction, and that you should see the pencil rotating in the opposite direction. Say there's a 10-second lag. There you go. So that's a rather large movement, obviously, because the water's warmed the sensor up very quickly. That's at 28. That's shot up to 28.56 degrees almost straight away. So it's a very small movement. Back in the peas, and they will bring the sensor temperature down reasonably quickly. But obviously, there you go. So it's heading back. I don't know, and obviously the number of steps per degree is completely dependent on your imaging setup. So the idea is that you use the logging function during an evening's imaging. So you manually focus during an evening's imaging, and it's logging temperature against position. Once you've got this file of temperature against position, you can then use that data to work out, either manually by plotting it, or using something like simple linear regression, or to work out your expansion coefficient for your particular imaging setup. Once you've got that coefficient in steps per degree, you can put that number back into the driver, turn the compensation on, and then the compensation will occur automatically, and then you can have as many of those coefficients as you want for each setup. I personally don't use temperature compensation because I don't find my refractor suffers that badly from for temperature drift, and a cold night in the UK tends to stay kind of pretty much a cold night. But if you were using a large Newtonian and the temperature dropped a lot from when you were setting up to when you were imaging, then obviously you could be out by your focus could be out by miles. And I've seen it drift even on my sort of relatively small Newtonian. I was having to refocus sort of every hour or so. So anyway, that was a quick, just a quick demonstration to show it in practice. Really, it's really easy to set up. You just plug your numbering, plug your hysteresis on, turn your logging on if you want it, and away it goes. I mean, you can use the logging function to log temperature against position without running temperature compensation. They're two separate functions in the driver. They operate mutually exclusively, or you can operate with compensation and logging on at the same time if you want. So anyway, thanks for watching. Any questions, drop me a note. Okay, cheers.